66 million years ago, the Cretaceous ecosystem was already destabilized. Long before the asteroid arrived, the planet's life was struggling against millions of years of shifting global climates. Much of this stress originated in modern-day India, at a site known as the Deccan Traps. For 2 million years, massive volcanic eruptions here pumped greenhouse gases into the atmosphere, causing temperature fluctuations that strained the world's vegetation. Then the final blow arrived. A rock between 10 and 15 kilometers wide struck the coast of modern-day Mexico at extreme velocity. The collision carved out the Chicxulub crater, a basin 150 kilometers wide centered on the Yucatan Peninsula. The immediate blast and resulting tidal waves devastated the surrounding continents, vaporizing everything in the impact zone. This regional explosion was catastrophic, yet a single blast was not enough to eliminate 3/4 of all species on Earth. The true extinction mechanism was global, not local. The impact pulverized the Earth's crust, ejecting billions of tons of vaporized rock, soot, and debris directly into the upper atmosphere. High-altitude winds carried this material around the world, creating a dense shroud that blocked the majority of sunlight from reaching the surface. Proof of this global fallout exists in the rock record today. A distinct layer of iridium-rich clay marks the boundary of the extinction event worldwide, showing that the debris from the asteroid eventually settled over every continent. This period of darkness caused temperatures to plummet and halted the biological processes that supported the planet's food chains. It was a global starvation event. The collapse began at the foundation. Without adequate sunlight, plant growth across the globe stopped, removing the primary energy source for all land-based life. Giant herbivores like Triceratops were the first to suffer. Their massive size required a massive daily intake of vegetation. When the plants died, these animals had no way to sustain their metabolism. Apex predators followed. A Tyrannosaurus rex required a constant supply of large prey to survive. As the herbivores died off, the largest carnivores on the planet quickly starved. Data from the fossil record reveals a clear survival threshold. Following the impact, virtually every land animal weighing more than 25 kilograms, about 55 pounds, died out. There simply wasn't enough food to support a large body. For 180 million years, physical size was a primary evolutionary advantage. In the impact's stark aftermath, it became a fatal flaw. Plants survived the famine through dormancy. Their seeds and pollen could remain buried in the soil for years, waiting for the sunlight to return and the environment to stabilize. In the oceans, giant marine reptiles vanished, but tiny plankton survived. Their minimal energy requirements allowed them to endure the collapse and eventually rebuild the marine food web. Early mammals passed through the bottleneck by being small and generalist. Their size allowed them to burrow away from the extreme cold, while their ability to scavenge on insects and decaying matter kept them alive when larger food sources vanished. While the giant dinosaurs died out, one small lineage endured. These were the avian dinosaurs, the ancestors of modern birds. These early birds survived because their beaks could process a wide variety of foods, including seeds, and their low caloric needs allowed them to persist through the years of global famine. The asteroid acted as a ruthless filter, selecting against the massive and the specialized, while favoring the small, the dormant, and the adaptable. When the atmosphere finally cleared, the planet was empty of the giant creatures that had monopolized its resources for millions of years. After the extinction, it took millions of years for animals to begin evolving toward larger sizes again. Large mammals only reappeared 15 million years later, during the Oligocene epoch, the first point since the extinction that rhino-sized animals occupied the landscape. As mammals grew, the surviving avian lineage also diversified. Some ancient birds even temporarily filled the vacant roles of large, flightless predators. Dinosaurs remain a part of our daily lives. The avian survivors diversified into the birds that occupy every corner of the globe today. The Chicxulub asteroid ended the era of physical giants. By removing the species that monopolized Earth's resources, the impact allowed the small, the dormant, and the adaptable to diversify into the modern ecosystem.